Hello, welcome friends. I am Tanmay. I welcome you all in my channel Chemistry the Mystery of Molecules. So today we will discuss about the preparation of carboxylic acid. Carboxylic acid is a very important organic molecule. So we will discuss about its preparation. So mainly we will focus about generalization, then few examples. So this video will cover that. Means general way to classify the strategies of this carboxylic acid preparation and some example or name reaction related to this. So in this video it will be a completely brief description, and for details I guess majority of case I have uploaded videos, and wherever not I shall upload in future. And if you think that any reaction I am mentioning here which I have discussed, please mention in the comment box. I shall try to upload corresponding videos with complete mechanistic description. Okay, so let's start. So as you can see, this carboxylic acid preparation could be achieved in many ways, like for example oxidation. Means carboxylic acid, this could be prepared by the way of oxidation. Okay, so one part should be oxidation, another could be reduction. Why I thought about this? So if this is a carbon, if you consider this, means apart from formic acid, this oxidation state of this carbon is +3. Okay, so we know that carbon can have maximum oxidation state, that is +4, to maximum reduction I can say -4. +4 carbon dioxide, -4 is, you may consider, methane. So from this oxidation state we can prepare. So oxidation, reduction, fine. So these are the main. One of oxidation is, one we can say side chain oxidation. One could be. Second could be oxidation of ketomethyl group. Okay. Another third way could be, means this part is also has a name. The name is haloform reaction. Haloform reaction. Okay. The third part could be, means okay, side chain oxidation means the, for example, toluene to benzoic acid, those type of thing. Oxidation of this ketomethyl group. Oxidation of lower, oxidation of CO bond having lower oxidation state. What do I mean? Lower oxidation state. What do I mean? For example, you may consider alcohol, you may consider aldehyde. These are lower oxidation state, or ketone. Okay, so such type of could be such type of processes could be oxidation. Another thing, reduction. Reduction is, as I say, this is +4, this is +2, means reaction with CO2. This is one possible. Okay, and apart from these two, another possibility could, what? That is from same oxidation state. From same oxidation state. What do I mean? +3 oxidation state, similar like carboxylic acid derivatives like ester, like nitrile, like amide or anhydride. These are not that much important, I believe. This part 1 and part 2, these are mainly important. Part 3 is not that much because these are the carboxylic acid derivatives. Okay, let's continue the oxidation part. As I told that this video will be brief, I am not going to explain any mechanism. If you need, mention in the comment box, I shall explain. I shall again upload video about the mechanism. Okay, so the first part you can see, it's a toluene aromatic hydrocarbon with the benzylic. This is a benzylic carbon, and in presence of strong oxidant, very strong oxidant like carbonyl, K2Cr2O7, V2O5 oxygen. These are all the different. This is in acid. This is in acid like sulfuric acid. You may consider, and this is V2O5 oxygen, etc. Oxidizes. So this is thing. Not only that, if you take this naphthalene and heat in presence of this V2O5 oxygen, it will result you in phthalic acid. Okay, and under reaction condition it will not be acid, it will be anhydride. It will be converted into -1 molecule of water. Okay, so this is actually called side chain oxidation. Side chain oxidation. Fine. Okay. So this is the side chain oxidation. So any aromatic hydrocarbon having the such side chain could easily be oxidized to the corresponding aromatic side chain and carboxylic acid. So this is in this context I want to mention that instead of other means I am always saying that okay, you need to have more than benzene. Fine. But if you take only the benzene and perform the oxidation, benzene will be oxidized to prepare dicarboxylic acid. Okay, so that is also possible. Fine. So the second one, this is actually the reaction of this ketomethyl in presence of alkali like sodium hydroxide, or you may use COOH, and halogen which is chlorine, bromine, iodine. Actually instead of that another reagent could be given NaOX, that is hypohalite. Okay, sodium hypohalite here. So this is nothing but haloform reaction. I have already uploaded video explaining this haloform reaction in details. In previous case, it was essential to be aromatic nucleus, benzylic, but it could be both aliphatic as well as aromatic. Okay, both possible. So this is the haloform reaction, and after reaction, see this medium is alkaline, so it need to be acidified. That's why this H3O plus given, such that alkaline medium could be converted into the acidic medium. And because in alkaline medium carboxylic acid remains as a carboxylate salt, so to achieve carboxylic acid it is essential to have a acidic solid. Means what? Means very dilute acidic. I should not say acidic. Very dilute acidic such that it remains in the COH form. Fine. Now, this one. This is the oxidation reaction. Oxidation of, this is alcohol. I can say this is alcohol, or this one could be aldehyde or ketone. This part mechanism means this oxidation of alcohol and carbonyl I have explained in the oxidation of alcohol and fate of chromium reagent. You will have a complete understanding from that video about this process mechanism. So in acidic medium, these are oxidized to produce the carboxylic acid. In this context, one thing should be remembered. So for example, this is R1 and this is R prime. R. So there are multiple possibilities possible. If you oxidize this ketone, this may break here to prepare R prime COOH. This may break here. Means if this part is COOH, this part will also be RCOOH. This part will be oxidized. So if it breaks this side, but this is possibility number 1. Okay, and if the possibility number 2, this part breaks, it will result, means this means I should say R minus 1. If it is N carbon, so this is N minus 1 CO2 plus R CH2 COOH. So this is not a very good method to prepare carboxylic acid. Okay, keep it in mind, but just as an example I have given. But this alcohol case, you can have carboxylic acid. And why? We know that alcohol is intermediate as converted as aldehyde, fine, and then it converted into acid. So if we need to get aldehyde, we need to have a special setup, and this explanation you will find one of my video already uploaded, oxidation of ethanol to acetaldehyde. If this aldehyde is not separated from the reaction mixture, it will be oxidized and ultimately end up with carboxylic acid. Fine. So this is the next example. The next example is actually you can say the reaction means oxidation and reduction both of an aldehyde, and this reaction is known as Cannizzaro reaction. I have already uploaded a video about this Cannizzaro reaction, so details you will find from there. I shall provide the corresponding link in the description box. So here two molecules converted into a condition no alpha hydrogen. Okay, so no alpha hydrogen containing aldehyde in presence of alkali, it converted, one molecule is converted into alcohol, another is converted into corresponding carboxylate salt. Remember, the medium is alkali. So after acidic workup, the acid is obtained. Similar another reaction is, for example, if you take acetaldehyde, this is alpha hydrogen containing aldehyde, so that could be converted into using aluminium isopropoxide, and it could aluminium alkoxide, and it could be converted into ester like ethyl acetate, OCH2 CH3, and this reaction is named as Tishenko reaction. I have already uploaded a dedicated video about explaining this Tishenko reaction mechanism, etc. Please go through that for understanding. Oh, this one. And here in this series, the last one is little interesting. Why I am saying, keep it in mind, the last one is dedicated for aromatic system. Aliphatic system, it will not occur. Okay, so this is the interesting part of this last example. So this is for aromatic, and this is actually diazotization reaction. Diazotization reaction. So what happens in ammonia NaNO2 HCl? It produces HNO2, and this HNO2 reacts with this NH2 and produces diazonium chloride. Since it is HCl I have used, so it should be diazonium chloride. Okay, so this diazonium chloride, and keep it in mind, this reaction always done 0 to 5 degree centigrade. 0 degree to 5 degree centigrade. If you heat, this will decompose. So fine. And in the next step, this is called cuprous cyanide. This is a Sandmeyer reaction. Sandmeyer's reaction. So what happens? This part cyanide get attached. So this, and next step is the hydrolysis of cyanide. Okay. So hydrolysis of that, because this is also a +3 oxidation state. This is simple hydrolysis. Okay. And in this context, I will give you little explanation about the hydrolysis of ester or amide, or anhydride. What I have explained, this is not that much important, but for lower means high school student, you may need it. So this is what happens. This is, so if we try to understand this little bit, so what is expected, that this reaction could be, this hydrolysis actually could be done in both acid or alkali. So let's discuss about the alkali case. Okay, so this hydrolysis, it could be done both in H plus or HO minus. And if you do the H plus, ultimately you will get RCOOH, OH plus, let's consider this R prime. So this is R prime OH. And if you do the alkaline medium, then you need to neutralize by workup, that is H3O plus. H3O plus and and H3O plus. Okay, and all this case reflux is needed to perform this because it is not that much easy to hydrolyze. So this is ester, this must be amide. This must be amide. RCONH2. So it is better to follow the hydrolysis in presence of alkali. The reason is, after this hydrolysis, what will be the product? Product is RCOOO minus plus ammonia gas. And in alkaline medium it will not be soluble, so it will go outside. And second step, H3O plus acidification will result carboxylic acid. Fine, but why I preferred alkali? Instead of, if you do acidic workup, then what is expected? Hydrolysis will happen. It will result in RCOOH. Fine. Along with that, it will result ammonium salt. So ammonia, for example, whatever ammonium salt will be produced. So this is better because you will get pure product. Second, another thing is that alkali is not volatile. Sometimes acid may be volatile. So that is another precaution carrying out the reaction. So it is better to choose a method which is safe from laboratory point of view. Okay, fine. And this anhydride is very active chemical. Very active. Keep it in mind. Very active towards hydrolysis. Why? Because see, this 2 carbonyl is attached to 1 oxygen. In this case, 1 carbonyl attached to 1 oxygen. So this is very active, and if it have a chance, if it get any chance to get water, what it will do? Let's consider this part. So the H plus part. So HOH, if we think, these oxygen will take the H plus delta positive because this is delta negative and this is delta positive, and this delta negative, this part will go and attack. So ultimately result 2 molecule of carboxylic acid. So in this case, it is not essential to have any other acid or base. If you give, the reaction will happen, but reaction will happen violently. Similarly, another derivative is acid chloride. It is a very active reagent, so if you provide water, ultimately it will convert into acid. Okay, but these are not that much important reagent. So last, let's discuss about the carboxylic acid preparation from carbon dioxide. Okay, let's come to the last part of this talk, which is CO2 reduction. Okay, CO2 reduction will result in carboxylic acid. So in this context, the basic concept is that if you see carboxylic acid, this is delta plus, this is delta minus. So this center is electrophilic. This center is electrophilic. So what do we need? We need a nucleophilic carbon center. And for that case, you see these minus means Grignard reagent, RNGX or RLI, both contain nucleophilic carbon. Nucleophilic carbon atom means carbon ion. Actually, they are you can say carbon ion. And in this context, I want to say that I have already uploaded lectures about the Grignard reagents property, organometallics chemistry basic. You may have the idea about the negativity. Alkyl lithium I didn't upload, but very soon I shall upload. So please go through it. So what happens? These negative charge, this carbon ion attacks and it opens up. And carbon dioxide, you can consider it is as a dicarbonyl, electron deficient. So attacks and it opens up. So ultimately first phase, what it produces? First phase it produces RCO, O minus and M plus. Okay, because if MgX or lithium, whatever this, and after that, if you do mild workup using H3O plus, means very dilute acid, then you will have carboxylic acid. Okay, and in this context, so not only carbon dioxide gas, you can use dry ice, which is solid carbon dioxide, means carbon dioxide is in solid state. So that can also result the same product. Fine. So let's discuss the second strategy. This reaction is known as Kolbe reaction. Kolbe reaction or Kolbe-Schmidt reaction. Kolbe-Schmidt reaction. The spelling may be little wrong, I am not sure, but the reaction is this. So what does this reaction? This reaction, alkaline phenol react with carbon dioxide, first and second work up in presence of aqueous acid resulted in, this is actually salicylic acid. Salicylic acid. Okay, so this is, and how this reaction happens. So first of all, it converted into this phenol converted into phenoxide, and that's why this became more nucleophilic. Consequently, you may consider that this is consequently it pushes and this attacks, opens up similar and produces the carboxylic acid. Actually initially the salt, and the interesting point is that initially the salt and after that work up acid. The most important point is that, see, these are very strong carbonyl, very reactive reagent. That's why, means at normal condition, even dry ice solid or 1 atm CO2 is essential to perform is enough to perform this reaction. But in this case, for this we need 100 atmosphere pressure, means the 100 times of the atmospheric pressure is needed for this process to carry out this. And another interesting point, instead of sodium, if you use potassium, it will result in para-hydroxybenzoic acid. Okay, this is because there is a chelate formation in presence of sodium. I shall upload a video dedicated about this process, so you will have a complete idea. So this is para-hydroxybenzoic acid. Okay, so this is the overall description. So this is the end of this discussion, and right now I have some personal comments, completely personal understanding I want to share with you people. What is this? We are going to prepare a carboxylic acid. My personal opinion is that it is better to use a safe route. Safe route means the method which will not create waste for environment. Why? Because if you use those potassium permanganate, dichromate, other transition metal, they are hazardous for nature. So better to use less hazardous reaction. In this context, you may think, okay, these RLI, RMGX, these are better, safe, because magnesium, lithium is not harmful, not that much harmful for environment. Fine, but they are difficult to prepare. Okay, so it is essential to prepare proper or produce proper method such that it produces very less amount of waste. For example, one method is very important, that is vanadium pentoxide and oxygen. Means oxidant is oxygen. Oxidizes naphthalene into phthalic anhydride. That example I have given. It's a green method, it's an industrial method. And this Kolbe-Schmidt reaction, it's a good but disadvantage is CO2, high CO2 pressure. But from chemical waste point of view, this is safer. So we need to think how to fix CO2 under milder condition. This is essential. Another thing, if we can prepare something from CO2, this is good, because right now in our environment lots of CO2 are there, and that is causing global warming, climate change, lots of destruction, blah blah blah, and whole human civilization, or better to say the whole living system of this planet is under danger. So better to find out some technique or follow some technique which is environment friendly. If we start thinking today, maybe tomorrow or day after tomorrow, we may have some idea to achieve this process. So for environmental point of view, we also think about a chemical reaction. It is not our exam clear point of view that okay, we have to clear the exam, that's why we are reading. It is not. We have to think what will be the consequence of nature, because we are not dumping anything anywhere. We are throwing or we are storing this harmful reagent in our own environment, and without environment we can't survive, because our water will be polluted, our food will be polluted, and consequently we will be polluted. So that is dangerous for our life. So I'll not elaborate this thing, but I request you, please think about it. before doing any reaction or before thinking any scheme or strategy, please keep it in mind. Ask one question to you. Is it environment friendly or not? If yes, go ahead. If not, please think. Try it to spend some time to think. Can I make it environment friendly? So, if you try, initially you may be successful, may not, but prolonged effort will make you successful and efficient. So, thank you everyone. So, this is the end of the discussion. So, see you in my next video. God bless you.